For the next couple of slides, we'll talk about obtaining some descriptive statistics. For those of you who feel comfortable with tidyverse package for data cleaning and grouping, feel free to use them. For the purpose of this class, we'll just use brackets and dollar signs to get the subset of data. First, we start with some numeric descriptive statistics such as mean and standard deviation. Suppose we are interested in calculating the average speed from the roller coaster data. We can use mean command to calculate the average. Notice that the inside of bracket has space for two numbers separated by comma. The first number is for the row, and the second number is indexing for the column. If you leave the space blank, it will keep everything for the blank location. Here, empty, comma 12 means all row values for 12th column, which is actually the speed of the roller coaster. So the mean parenthesis coaster bracket empty comma 12 means that mean of the speed of the roller coaster. We can do the same thing using dollar sign. Coasters dollar sign speed on underline MPH finds all values of the column speed underline MPH. Thus, it will give the exactly same answer as the previous code. It will be slightly easier to understand your code if you are using dollar sign and specific variable names compared to using the brackets. We'll also calculate the standard deviation of the roller coaster speed using SD command. We can use let's see. Often it is useful to have template code available to make a pretty table. This slide is optional, but might be actually very useful when you do the project and you want to make cleaner tables. There are several different ways to do this, of course. Here we'll explore one of the options called Cable Extra Package. First, we install the package. We define an object A as a data frame with variable, mean, and standard deviation column. We specify the element of those columns using C command. By using KBL command and cable underline styling command, we can make different styles of the table. The provided one is just the default setting. Feel free to copy and paste and update the code as needed. Now let's talk about some graphs to describe the data. We'll introduce ggplot2 package here. Suppose we want to make a histogram for speed of roller coaster like the graph on the slide. First, we load ggplot2 package using library command. Notice that we don't need to install the package again since we already installed this package before. The next line of the code sets a ggplot of object A with the data set coaster and variable name speed on the line MPH. Notice that the variable names are listed inside the AES function. AES stands for aesthetic. Here we only add one variable, speed on the line MPH, since we are only interested in drawing histogram of one variable, speed. Now we'll add graphics to the object A using adding sign. Zoom underline histogram will draw histogram. Here we want the beam width to be 10 and the color to be blue. Then we also add the labels using labs command. X label goes with X axis, Y label goes with Y axis, and the title, we can add the main title of the graph here. The last two lines will generate the histogram of the slide. From the graph, we can say the speed of roller coaster is approximately symmetric. A roller coaster inversion is a roller coaster element in which the track turns riders upside down and then returns them to the right side up, upright position. Inversion variable represents the number of inversions of roller coasters. Here we want to consider the inversion number as factor, not numeric variable, but factor, and draw a bar graph. Notice we begin with similar code from the previous slide. First, assign A as a ggplot object with the data set, and we add the variable in AES command. Note that inversion is considered as factor. Now we start to add some details of the graph. Zoom underline bar command will draw a bar graph, and we can specify some options. Here we are using the count of each category as the stacked. This is the default, and the bar is with 0.7 width and still blue color. The option theme underline minimal changes the background of the graph as minimal. From the bar graph, we see there are a lot of roller coasters do not have inversion. If they do, the number of the inversion is between 1 and 7, and the most common numbers is 3. There are two different types of roller coaster. One is made with steel and one is with wood. We are wondering if there is a difference in speed for two different types of roller coaster. Let's draw a box plot to see what we can find, just like it is shown on the slide. Again, we first define ggplot object A with X as a type of the roller coaster, so like type steel or wood, and Y as the speed of the roller coaster. Notice that we need to define two variables this time in AES command. Because we need box plots of the speed for two different types. Zoom underline box plot will generate box plot, and here we want those boxes filled with pink and blue color. From the side-by-side box plot, we can see the median speed of wood roller coaster is faster than the steel one. More interestingly, the steel roller coaster have much bigger variation in speed than the wood ones. When we're interested in the relationship between two numeric variables, we often want to draw a scatter plot. In our roller coaster example again, suppose we want to see if there is any relationship between the speed and the maximum height of roller coaster. You know, if the height is really, I guess, high, if it is a tall one, you know, when you go down, it probably will have a faster speed, maybe. In ggplot command, we define X and Y variables. Geom underline point command will put points on the plot and draw a scatter plot. Then we can add optional, but we can add linear regression line using stat underline smooth command with the method option as LM. LM typically, LM actually stands for linear model, and it is typically means linear regression method is used. Of course, there are various different methods other than linear regression we can use, but we'll not worry about those, just not yet. On the scatter plot, we can see potential positive relationship between the speed and the maximum height, which is not really surprising.